Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be taking a look at what we can see in the sky, specifically with binoculars. I often say whenever we take a closer look at something in the sky that you would need a telescope or binoculars if it is a close enough object or a visible enough object. People don't often associate binoculars with astronomy. Binoculars normally get associated with birdwatching or hunting or potentially the opera or the theatre, whereas telescopes are what we think of when it comes to astronomy. If you tell someone to think of a telescope, they'll often think of looking at the stars. And usually when people think of studying the stars, they think of using telescopes. But binoculars can be a very useful tool for performing astronomy. We are looking at the evening sky here, just a little bit into the future. The new moon is coming up soon, and the moon will be very close to the sun over the weekend, which is good for observing faint objects, the kind of objects that you can't see with your eyes, but that you could see with a telescope. We also have Saturn just after coming up above the horizon. As you might be able to tell, we are looking at the sky from the city, so the glow of the Milky Way is pretty much invisible. We're only seeing the brighter stars. These are not great conditions, but they are enough to use binoculars. We'll start by taking a closer look at Saturn. Saturn is the most distant planet that we can see with our eyes. We'll push up to morning time to try and take a look at some other planets. We can see here with a small pair of binoculars, it just looks like a ball. And even if we use one of the more powerful binoculars, we're not really going to see Iapetus here, but a few days into the future, you might just about see Titan, Saturn's largest moon. That is the most distant planet you can see with your naked eye, the easiest moon that it has to see, and they're visible with incredibly big binoculars. Some binoculars are so large you really need a tripod to use them effectively, and if you have to use a tripod with them, you'd almost be better off getting a telescope. But binoculars do give certain benefits. You are looking with both of your eyes, so focus is an issue, and you do get it's a little bit easier to make sure that you're seeing something through binoculars. Binoculars are usually designed for you to put your eye right up to the lens or right up to the eyepiece. They often have a little plastic cup that your eye can sit into, whereas with telescopes, you're normally expected to put your eyes just a little bit off of the eyepiece. There's usually a little bit of a gap where you're supposed to put your eyes, and finding that gap and keeping yourself there, that can be a little bit tricky, especially to begin with. We are going to look for the Andromeda Galaxy, and the Andromeda Galaxy is pretty much here. We do need to click on something to use binoculars in Stellarium. Of course, in the real sky, you could just zoom in. You could just pull up your binoculars and point in a random direction. But we're going to start over here by Cassiopeia and have a little bit of a look around. So we can already see some faint objects here, and this is also looking from the city. There's two faint galaxies visible out there. These faint galaxies just look like fuzzy shapes through binoculars like this, but still, we can see that they're fuzzy, so we know they're not just a star. Coming down from Cassiopeia and down, here we go, down from those galaxies and a little to the right, here's the Andromeda Galaxy. And this is how we're seeing it through the city, from the city, with a pretty small pair of binoculars, 6 by 30. We can go up to bigger pairs of binoculars here, more powerful binoculars. Here's a great one that's really made for stargazing. 15 by 50 is already getting quite big, but you should still be able to hold that with your hands. Going much bigger than that, and you will start to need to use a tripod. So this is with a very big and therefore very expensive pair of binoculars, whereas a comparable view through a small telescope, well, it's comparable. With a small telescope, you can see something very similar to what you would see with a big binoculars. And those smaller telescopes are often quite a bit cheaper. So this is the Andromeda Galaxy with a big pair of binoculars, and even with a small pair of binoculars, you can see the dwarf galaxy orbiting around it just up there. So that is, of course, the nearest galaxy to us. But to quickly take a look at two galaxies we saw in a previous video, we'll point up to the end of the plough here, and just under that star, we've got the Whirlpool Galaxy. And it's pretty clear that it's a whirlpool even with this small binoculars. Once we go up to something a little bit bigger, and remember, this is all from the city. With a very big pair of binoculars, that's a very clear view of this galaxy. We'll hop back down to something smaller and we'll go up. The Pinwheel Galaxy, which I accidentally called the Sunflower Galaxy in the last video. It is a very big, very easy to see galaxy. Yep, just over there. So because it is closer to us than the Whirlpool Galaxy, it's even easier to see. It's even easier to see those arms. Taking a closer look with a bigger binoculars, and look at that. That's very clearly a galaxy. So this binoculars is giving you a better view, a clearer view, than some of the large telescopes that were used in the dawn of telescopic astronomy back in the 17 and 1800s. So technology has come a long way, and that is reflected in small binoculars and small telescopes almost as much as it is in the big ones. Of course, the bleeding edge of technology is focused on the larger telescopes, but smaller telescopes are incrementally improving over time as well. Now, as I mentioned, in Stellarium, you need to click on something in order to take a closer look. In the real sky, you can just point your telescope in a given direction. So over here, we've got a little bit of Sagittarius visible. You might just about still be able to see Antares there. And up here, we have the Summer Triangle. So we know this is where the Milky Way should be. So I'll see what I can click in here. It's an asteroid named Isis. There we go. So here we are looking into the core of the Milky Way, roughly at least. We'll go up a little bit from the horizon. And there are some of the colourful nebulas around the core of the Milky Way. The Trifid Nebula looks like it's that one. Of course, we are looking through the glow of light pollution and reasonably close to the horizon there, so it will be tough to see. There are fields of stars, more nebulae, and you can essentially follow up along the glow of the Milky Way to see these globular clusters of stars, fields of stars, and nebulae as this galaxy stretches across the sky. There's another interesting faint shape down in that direction. Here's another, oh, that looks like a ring nebula or a planetary nebula. It looks quite ring shaped. Let's take a closer look if we can. See how close we can get. Still pretty tough to make out even with the largest of telescopes, but I do want to know exactly what it is. The Snow Globe Nebula, which I do believe is a planetary nebula. It is. So nice and round. We can see that round shape even just with binoculars. Now, I'm sure it would look very impressive through a telescope as well, but that's not what we're here for today. Move through the Milky Way just a little bit more. I know that there's another interesting cloud of gas. There's another nebula over there. I know that there are some interesting things in and around the top of the Summer Triangle in the Milky Way, which is roughly the direction we're headed. You can see I'm kind of zigzagging up and down here. I'm trying to stay where the glow of stars is most obvious. There's another nebula up there, and you can see some of the internal structure of it. Here we go. Some of the big nebulae that we can see up and around the top of the Summer Triangle. So I'll bring up their names. There's the Inchworm Cluster, the Cooling Tower Cluster. I believe one of these is the North America Nebula as well. There's the Pelican Nebula, yep, the North American Nebula up there. And that's in Cygnus. That's just around the top, one of Cygnus's wings, I believe. You can see there's a lot of deep sky objects that we can't see, but we're definitely seeing some interesting clusters of stars. Even as we move out towards the edge of the Milky Way, which is less dense, less full of stuff, you can see that there is definitely a drop off. Move away from the Milky Way, the color definitely fades. The sky gets less bright. As long as you're looking into the Milky Way, you should see some fuzziness, even if it's not fuzziness you'd initially recognize as a nebula. We can see a little bit more color up there. Coming down the back, there's still more nebulae to be seen. And not only is this all with binoculars, this is all with binoculars from the city. You'd be able to see even more from the countryside. So, how far back have we gone? Yeah, just around back to Cassiopeia, close to the edge, the outer edge of the Milky Way. We're going to stay looking east as we move forward towards the morning here and early morning. Just to be safe, we don't want to look too close to the sun, even if we're only using binoculars. So here's our view of Jupiter. Going through a couple of days, I'll get rid of the names. It is tough to tell, but I think you should just about see the bulge there of one of Jupiter's moons. There we go, completely separated out to the side of the planet. That's wonderful. So even with the smallest that Stellarium has on offer, you can see the moons orbiting Jupiter. There are, of course, binoculars real life that will be too small to show you those kinds of details. Some binoculars that are binoculars that are dedicated to looking at the stage in a festival or looking at the stage in an opera theater, those won't quite give you this kind of magnification. Certainly not this much magnification, which is, again, using now a binoculars that would require, there we go, 3 moons visible through binoculars. Binoculars that would require a tripod to hold, but still. And even with a smaller binoculars, like this one here, the smallest that Stellarium gives you from the 1960s, so not the most advanced technology either, and there are moons orbiting around Jupiter. Now we have moved a little bit closer to the end of the month, so let's come a little bit back to today. You can see the sky's getting brighter, which will make things more difficult as well. We'll very quickly take a look at Mars and the Pleiades before we finish up. Mars is, of course, much, much closer to us, but the moons around Mars are so small, they're going to be difficult to see, even with a very big binoculars. The surface of Mars, you can see some detail on the surface of Mars with a medium to large telescope, but even the largest binoculars we have here isn't showing us that. So despite the fact that Mars is closer to us than Saturn or Jupiter, its moons are too small for us to see any of them. This is the Pleiades, or the Seven Sisters, with a massive binoculars, and there they are, with the small binoculars. And again, smallest that Stellarium will offer, and that's a fantastic view of all of the Seven Sisters, and all of this from the city. I'm sure you can imagine how nice that must look if you are in the countryside without the extra light pollution, and maybe I will do a binocular oriented video for dark skies in the future. But until then, you will have to subscribe to my YouTube channel to catch those upcomings, and if you enjoyed this video, please do like it. If you'd like to read some of this information, you can check out my website, queebeanscontent.ie, and no matter what you do, I hope that I see you back here next time.